Hey there guys, I thought I'd do another video, cutting another project here. This is MDF, 1/8 inch thick, preferably one of the more difficult things to cut when you get into thinner stuff, especially with plastics. But these are some door parts for a cabinet maker I know, and he is doing a kitchen, building the doors, and they're glass doors, and these are inserts that are going to go behind them, get painted like a satin black or gray, and to look like they were the old lead doors. So I was provided with a bunch of templates, so I had to take these. The customer was actually nice enough to cut out every single one out of paper. Must have been an older draftsman or something, because I don't think I've ever met a customer that had the patience to even draw, let alone make these out of paper. But it was really nice. They're not perfect, but at least they gave me the idea for every design for every door and the multiples and whatnot. There's about 30 doors total, and this is what they look like when they come out. Although the tabs, and they have to be sanded and cleaned up, but my client is a cabinet maker, so he's going to do that for me to ease up on the labor cost. And that's pretty much it. This guy goes behind the door, glass door, and it's got a 3/8 reveal and a 3/8 trim here, which will sit in a rabbet behind the back of the glass door, so it'll look like these ellipses. And I thought I'd show you. I got one more nest to do. I'm going to cut these out and clean this up. And I think I'll show you the last nest, because it's only a couple doors, not too long. A couple things I wanted to point out with this, and for those of you who are doing stuff like this, one thing it took me a long time to realize, and it wasn't until I got some AutoCAD drawings from a customer one time that had drawn them up for me, that I realized why it was doing this. And when you're working with ellipses and any kind of arcs like this, especially at least with V-carve and how it works, it'll treat an ellipse like an unlimited set of lines, you know, like it really is. Whereas an arc, as you all know, is just a simple mathematical equation of a radius and start and end point. And what I found is, no matter what you do when you're doing machine stuff like this, it's always better to have arcs, real mathematical contours. You know, when you're doing V-carving, 3D stuff, that is what it is, and that's the nature of it. But when you're doing 2D parts like this, if you have ellipses in any parts that you're cutting, it's going to cause you problems. Then you should just convert them. And I think you'll see in this nest, I didn't do all of them. I forgot to do a whole nest, part of this sheet. And what you'll see is the machine makes a real jerky kind of motion. It goes XY, XY all the time. And what it's doing, for those of you who remember algebra, I know this is kind of basic, but the ellipse is kind of a short, jagged set of straight lines. It's not an actual arc, although some people would say that an arc is just this infinite set of straight lines, but an ellipse truly is. If you look at the G-code, it's just moving XY all the time. And I don't think it really makes a huge difference in a part like this, because you're not touching and feeling the part. But I've seen parts where it will leave a nice jagged edge depending on how bad the ellipse is. So like I said, first tip, take all arcs like this, and all ellipses like this, and convert them to arcs, and you can just trace over them and snap to them in AutoCAD. I didn't do it on some of this here. I'm not going to go back and redraw it and program it, because it takes a long time to draw this stuff. It's kind of ornate. My machine could hold up to the beating, but I know some of my older machines, a smaller machine, would never. I mean, this stuff would just loosen up. I'm sure this is going to do a number on some of my bolts and bearings, because you see this head is just basically vibrating. It scared the crap out of me the first time I saw it happening, and it's just something to avoid. Also, with this 1/8 inch material, it's real difficult to cut out because it's hard to hold down. I think even if you had a vacuum table, I've seen almost always, I've seen on commercial machines, even with a vacuum table, you've got to leave an onion skin, because it's very difficult to hold down such a thin material. It's already warped and whatnot, just because it's not a stable thickness, especially being MDF. So it's got no strength to it. So I use spots of carpet tape, and I'll show it in this upcoming part. I didn't put full strips. When I do acrylic and plastic parts, I'll put literally full strips of carpet tape across. And I wish I could get a thinner width, but that's what I do. Just even though it's ultra crazy, there's not an easy way of holding this stuff down. I've got tabs on all these. On the smaller parts, I don't put tabs. Like these, this is probably as big as I'll go without a tab. These just pop right out. They're tiny little pieces. Either they're going to get rocketed out and shot into the dust collector, or they just get kicked out of the way, and they're not a big deal. The thing to keep note when you're doing small parts like this and you don't use tabs, you know, for stuff like this where it just doesn't really matter. It's an 1/8 inch piece. The router bit's is going to crawl right through it. Make sure your safe Z height is sufficient to whatever your thickness is, because I used to do it with this really low safe Z height, and when this thing cuts and then it climbs over here, sometimes the piece will get dragged up onto the surface, and if you're at, like, say 1/4 inch where I was, you're going to hit it. And if you keep it like 1/2 inch, you're just going to climb right over it. Usually not a big deal. It just kicks out of the way. It doesn't even hit it. But if you're doing solid wood parts, anything beefier, you might have a problem. I've broken a bit with thicker parts, 1/4 inch or 1/2 inch parts, and 3/4 if you're not careful. So anyways, that's enough talking. I'm going to show you my last nest and show you it cutting again, show you the machine running. And again, sorry if this machine looks a little jagged. It's not screwed up, it's just the geometry of all some of these ellipses that I left in here and forgot to trace. But that's pretty much it. Let me show you some cutting. Okay, so we're ready to get cutting again. I'm not going to home the machine because I've already been cutting some sheets, all the same thickness, all the same relative size. I'm just going to drop my feed rate down to 35 again. I was up higher just to kind of show it starting up again. Dust collector's on, and I'm ready to roll. I'm going to cut some more door parts. Not going too fast. I kind of take my time with these so I can keep my hands down the material at some points. No matter what it is, I just don't trust this material. It's like a little push sticks and I hold the material down sometimes, but we're all good to go. I'm just gonna cycle start. Tool check is good. It's gonna lower down safe Z. Spindle's on, and here we go. I gotta resurface this table. It's on its way out. You get to a certain point where the carpet tape is not as effective anymore, and this pointer is like my main work area. So I think it's kind of lost its, grip and tack-wise. So now here you're gonna see the problem I was talking about. Like I said, I'm not gonna fix it because it's just a lot of work, and I don't really mind this for what these parts are. But you'll see, because this is an ellipse, it's actually all this fitting up. It's probably really hard to see, but there's these fine oscillations. And that's just because it's trying to cut little lines instead of an actual mathematical curve. But for what I'm doing, I really don't care. Going to bump up the feed rate a little bit. Like I said, this screen is awesome. I'm going to go up to 50. Again, this is kind of a crappier MDF. These are actually seat covers for nice plywood. So it's a really cheap sheet of MDF material. But it was free, so it was customer supplied, so it worked for me. It takes about 3 minutes to cut each door, which sounds like a long time, but I'm making one pass. I'm not making multiple passes. There's virtually no cleanup other than sanding the fuzzies on the surface because we're using an up spiral. And it's not bad. To do this by hand with a scroll saw and get it nice and sanded, man, you'd be in a couple minutes. At least you'd be in 20 minutes a door, at least. So this works out nice. It's affordable for the cabinet maker and the customer. For now. And there she is, all said and done. 30 doors. Not bad for Sunday morning. Punch through those. Cut off the tabs. light cleaning. I won't be finishing these, so I'll take care of the rest. Put them in a box, and not a bad job. All said and done. That's another video of my Joe's Hybrid rack and pinion, and hopefully you guys liked it. Thanks very much for watching.